The librarian finds that the number of hours spent reading a book over a month, R, is dependent on the number of hours a person spends at the library over the course of a month, X, and can be modeled by this function. They want you to draw the graph by reading the graph of the reading function by plotting its R-intercept and another point. So when they say it's R-intercept, they're saying R because now our variable is R instead of Y. Like if you remember Y equals mx plus b from algebra, they're just saying R in place of Y. And so the y-intercept in algebra is always this number that was hanging out by itself, the one that was unattached from the x. So the r-intercept in this case is 26. Newton wants you to use its graphing program, put a dot up at 26, and they want you to plot another point to make the line, because we just need 2 points to make a line. And so to find the other point, you could use the slope. You know, that's going to be kind of hard to count out though, because it's 1.5 units. So if this is 27, it would be here on the y-axis, and it'd be over 1 on the x-axis. So that would be the next point. That's 1, 27.5. And again, I got that point because the y-intercept starts at x equals 0. A slope of 1.5 means you go up 1.5 and to the right 1, just like the slope, what the slope meant back when we were doing algebra. The other way of getting a point though is you can plug in whatever number you want in for x. Like you can plug in 10 in for x and see what it spits out for y, or another, in this case, see what it spits out for r. So if you plug in 10 into this function, you get 26 plus 15. So 26 plus 15 makes 41. So 10 on the x, 41 on the y could be another dot. It's Newton, and it's a piece of software, so there should be other points you can plug in. I just chose 10 at random. You can pick whatever value you want for x, plug it in, and see what it spits out for y. But if you plug in 10 in for x, you should be able to put a dot at 41 for y. 41 on the y-axis.